Bill Nye the Science Guy. Bill Nye the Science Guy. Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter.
Bill Nye the Science Guy.
T minus 7 seconds.
Bill Nye the Science Guy.
We can draw a diagram and label the first ball as having 0.17 kilograms. This hits this second ball with an unknown mass and recoils at a speed of 0.28 meters per second. And this ball moves this way at a speed of 0.24 meters per second. This is what we know. We know the final velocity of the first ball, the final velocity of the second ball, the mass of the first ball, and the mass of the second ball is unknown. Because of conservation of momentum, we can use this equation here, that the mass of the second ball is equal to the negative mass of the first ball times the velocity, the final velocity of the first ball, divided by the velocity of the second ball. We can plug the numbers in here, and this is what we get. We get that the mass of the second ball is 0.2 kilograms. Because this collision is an inelastic collision, there is a loss of energy. We can find this loss of energy using this process.
I'm afraid I can't do that.
The equation for kinetic energy is Ke equals 1/2 mass times velocity squared. We can plug in the mass of the original ball and the original velocity of the ball to find the original kinetic energy in this system, which is 0.026 joules, the initial kinetic energy. We can do the same using the same equation. We can find the final kinetic energy of ball 1 and the final kinetic energy of ball 2. We can take the initial kinetic energy and from it subtract the two final kinetic energies, which gives us the final kinetic energy in the system. You can see that there's a difference here, and this means that there is kinetic energy lost. Hey Tasneem, what are you doing?
Just watching this awesome Newton's Cradle video. Did you know that Newton's Cradle is an example of an elastic collision?
No, really? Tell me more.
An elastic collision conserves both energy and momentum, so they are equal at the beginning and the end.
Physics, eh? Physics. 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 I don't want you getting all this down. Oh.
Okay, the two objects bounce after the collision so that they move separately. Elastic collisions. There, okay, see. Imagine that we're dealing with the largest Newton's cradle in the world, and each ball weighs 6.8 kilograms. It's moving to the left, 0.225 meters per second. It's negative because it's moving to the left. We're going to try to find the final velocity of ball number 1. Yeah, that's all I got. Because momentum's conserved, we can use this equation to solve for the second ball's final velocity. When we plug all the numbers in, this cancels and this cancels because the ball stopped moving, and when you solve this, to no one's surprise, the velocity of the second ball is negative 0.225. We can confirm the answer that we got for the velocity by making sure that the kinetic energy is also conserved using the values. So if you plug, so the kinetic energy initial will be equal to the kinetic energy final. So if you plug them both in, then you can see that we did do it correctly because the kinetic energy is the same, which means it was conserved, which means it was an elastic collision.
Okay, so inelastic collisions. What you need to know is that two objects collide but do not merge together, yet energy is still lost.
That's what most collisions in the real world are.
Yes, most collisions in the real world are inelastic collisions.
Okay, so elastic collisions, perfectly elastic collisions, are the same thing, and it means the object bounce and they separate, and no kinetic energy is lost. No momentum is lost, nothing is lost. They just
second law of motion.
Yes.
Just nod.